So right now, there are three storage solutions in the market: a hard drive, a SATA SSD, and an NVMe. But first of all, let's get through what an NVMe is. First, a quick note about SSDs. They're fast. So fast, in fact, their limiting factor is not their own hardware, but the SATA III connection that hard drives have traditionally used. Enter NVMe, standing for Non-Volatile Memory Express, is an open standard developed to allow modern SSDs to operate at the read and write speeds they're maximally capable of. Essentially, it allows for flash memory to operate as an SSD directly through the PCIe interface, rather than going through the SATA and being limited by slower SATA speeds. Put in it basically, it's a description of the bus component used to communicate with the PC, not a new type of flash memory. It is also unrelated to the form factor, which is why NVMe drives come in both M.2 or PCIe card form factors. PCIe cards are extremely expensive, nearing $1,000, so while NVMe's are only $100, well, PCIe is like 10 times more. So PCIe is far in the future. Basically, the difference between SATA and NVMe is that SATA and NVMe are basically the same thing. But since SATA is built into a hard drive, it's limited by its hard drive, or it's limited by its exterior, since it's designed to be a hard drive, except it's really just an SSD inside a hard drive case. So what they did is that they just took the SSD out of the hard drive case in order to not limit it, so it could go at its maximum speed. How does NVMe speed compare to SATA? Modern motherboards use SATA III, which maxes out at a throw output of 600 megabytes a second, or 300 megabytes a second for SATA II. Basically, this is it. A hard drive has a delay since the thing over here, since the actuator has to go in the correct position, which would take about a tenth of a second, which is a lot, and that is basically a delay. And by the way, a hard drive can transfer data at about 180 megabytes a second. Since an SSD or a solid-state drive has no moving parts, its delay is only between a thousandth of a second to 3,000ths of a second. And the SATA SSD can transfer data at 600 megabytes per second. While the NVMe, on the other hand, has basically no moving parts. And since this is the full form factor of the NVMe, which is basically non-volatile memory express, and since it's not built into the traditional hard drive, it's able to run at its full capacity at 3 gigabytes per second and a delay of 1/10,000th of a second. But this doesn't mean loading times are 10 times to 100 times faster in the games. No. Since NVMe and SSD are basically the same thing, except the NVMe isn't limited by its hard drive outer case. So this is what an NVMe SSD looks. On the bottom is the NVMe. As you can see, in the bottom, this is it, the NVMe. On the bottom is the NVMe SSD. So yes, most SSDs are built around NAND flash, which is basically a hard drive with, except it's not a hard drive. It's basically just a bunch of electrons stored together. And when you use that electrons again, they create the NVMe SSD, or the SSDs. And then into the near future, we have PCIe 4.0, what I'm talking about, up to 6 gigabytes a second. But that's really far into the future, since it's about $1,000. And GTA 5 loading times, an M.2 gets 52 seconds, SATA gets 53 seconds, and a hard drive gets 1 minute and 32. So it's better to just use a SATA since there's